Okay, so today we are looking at simultaneous equations and solving simultaneous equations. Now we already know what the word solve means. Solve means to find out your knowns, but we don't know what a simultaneous equation is. So first of all, let's just get down the definition of what a simultaneous equation is. A simultaneous equations are a set of two or more equations with more than one variable that can be solved. Simultaneous equations are a set of two or more equations with more than one variable that can be solved. So that's the first thing we need to write down. Is simultaneous. So if we have a look here, what do I mean by that? Well, if we have a look at this one down here, just having a little look down here at this one, just before we continue. Look, we've got two equations here, equation 1, equation 2, and we've got two different unknowns. We've got P and Q in that one there. So this is an example of simultaneous equation, and we'll talk about more about that in a second. So let's just write down a little sentence. Now, we know what the word solve means. So let's just talk about how we solve simultaneous equations. So when we solve simultaneous equations, we are trying to find all of our unknowns. Unknowns are on there, haven't they? Have I? Unknowns. There you go. When we solve simultaneous equations, we're trying to find all of our unknowns. So here, with this one down here, we'll be trying to find P and Q. Okay, I'm just going to add one more thing. Now, this is a very important definition. We've got a few definitions here, actually, haven't we? So, next little thing. Now you'll notice in our title today we talked about the word coefficients the same. So I want you to know what a coefficient is. So I'm going to always spell this wrong, efficient is the number in front of our letter. That's what a coefficient is. So we've got a coefficient is the number in front of our letter. Okay, so we've defined what simultaneous equations are. we know that when we're trying to solve simultaneous equation, we're trying to find all of our unknowns, and the coefficient is the number which is in front of our letter there. Okay, so now this is an important part to helping us. Okay. Now, this part here probably isn't going to make sense just yet, but we will use this a lot, okay? We'll talk about it in a second, okay? So, if the symbols on the term that if the symbols on the terms that are equal are the same, then we subtract our equations. We'll talk about what this means in a second, just get it down for now. If the symbols on the terms that are equal are the same, then we subtract our equations. And the next one, if the symbols on the terms that are equal are different, then we add our equations. Now this part here is probably the most important one here, so I'm just going to now put a square around this one because this one is really important, and I'm going to highlight two parts of this. So if the symbols on the terms that are equal are the same, so if the symbols, let's highlight the symbols, are the same, so if the symbols are the same, then we subtract. Okay? If our symbols are the same, then we subtract. And let's highlight something else. So if the symbols are different, then we add. Now this is the important part, okay? So make sure you've got all of that down. I'm going to give you a little second to get that down. Let's put a box around this. So, we've just had our definition. So we know that simultaneous equations are a set of two or more equations with more than one variable that can be solved. We know that when we're solving simultaneous equations, we're trying to find all of our unknowns. Okay, so there's more than one unknown. Another word that we need to think about is the coefficient. So the coefficient is the number which is in front of our letter. And then we had this definition which was going to help us. So if the symbols on the terms that are equal are the same, then we subtract our equations. And if the symbols on the terms that are equal are different, then we add our equations. Okay, so let's have a little look now at some questions. Now I'm going to do both of these. Okay, so example 1, example 2. So this one here is example 1. And it'll start to make a little bit more sense now. So you'll notice here that we've got two equations. Okay, and I want you to get these down, and I'm going to label these equations 1 and equations 2. Yeah, like so. So the question I'm asking myself here is which of the letters are the same? Well, the letters which are the same in this one are that Q. So what I will do with this one, you can either circle this or highlight it. I'm going to circle these Q's here. And then I need to think about this. So if the symbols on the terms that are equal are the same, then we subtract. And if the symbols on the terms that are the same are different, then we add. So what are the symbols on this Q? Are the symbols on the Q the same, or are they different? Well, we can see that it's both add Q. So what I'm going to do is I will say on the side, because these, so in fact let's just write a little reason why, just for this first one. So because the symbols on Q are the same, we subtract our equations. So because the symbols are the same, we subtract, which is what it says up here. If the symbols are the same, we subtract. Now you're going to see the reason why that we subtract, and this is what's called elimination. What we're doing is we're eliminating one of our terms. Okay, so if I just underline this here, oh, terrible underlining. If I underline this here, there, like so, and then I'm going to subtract my equations here, like so. I'm going to subtract my equations. Now what you're doing is, notice they're already in line. So what I can do here is I do 5p take away p, which is 4p. I do q take away q. Well, what is q take away q? Q take away q is 0, which is the whole point. We've eliminated that. Okay. Then we have 23 take away 3, which is 20. So what we've done is we've subtracted our equations to eliminate q. And in fact, I'm going to write that down as well, because that's really important. We've subtracted our equations to get rid of Q. So we've subtracted our equations to get rid of Q. I'm going to put a line there so you can say these are our notes. We've subtracted our equations, I should say, to get rid of Q. And then what we do is we just solve this like a normal equation. So with this one here, 4p is equal to 20. Well, if I want p on its own, I need to divide by 4, divide by 4. So 4p divided by, now this is what we did when we were doing linear equations. So 4p divided by 4 is p. 20 divided by 4 is 5. So now we know that p is equal to 5. Now we've not finished there, because we noticed that when we said it above, when we're solving simultaneous equations, we're trying to find all of our unknowns. So we know what p is, but we don't know what q is. Now this is the next and the last little part here. I'm going to write this down as well. We sub p back in to find q. So what I'm doing is I'm taking this p, which I now know is 5, and I'm going to put it back in. Now I'm going to put it back into this equation here just because it's a little easier. So I now know that p is equal to 5. So I can write down equation 2, which is p plus q is equal to 3. And I know that p is equal to 5. So what I can do is I can put this into here, which gives me 5 plus q is equal to 3. And then I'm just going to solve the last little part. I'm going to solve this, which is minus 5 minus 5. So I end up with q is equal to 3 minus 5, which is equal to minus 2. So I've got two solutions here. I'm going to highlight both just so we know. We've got p is equal to 5. That's the first one I've found. And I've also got q is equal to minus 2. And that's it. That's this question done. Now, it does seem tricky at first. So p is equal to 5 and q is equal to negative 2. Okay, this does seem tricky, but when you get used to it, it's not too bad. So that one there was example 1. There we go. So I'll give you a second just to get that down. So let's have a little look at example 2 then. Let's have a little look at example 2. So, example 2, this is our example here. So with example 2, now the question is which of my symbols are this? Which of my coefficients are the same? Well, the coefficients are the same on Q again. Look, we can see that the coefficients on Q here are both 3. The coefficients on Q are both 3. Now, what are the symbols on those? So here, if the symbols are different, then we add our equations. Okay, so with this one here, so let's write it on the side. Because the symbols on Q are different, we add our equations. Okay, so because the symbols are different, we add our equations. So let's do that now. Now I'm going to just label these again like I did last time. I'm going to label this one here 1. I'm going to label this one here 2. And because the symbols are the same, we're going to add these equations. Now, the reason that we're adding these is again so that we can eliminate Q. So notice, now the reason that we're doing this is because, well, let's do it, let's go through it then. 4p plus 5p is equal to 9p. Now, what is 3p plus minus 3p? Well, 3p plus minus 3p is equal to nothing. That's the whole point. 3q plus minus 3q is equal to 0. So that's eliminated there. And then the last one is 5 plus 13, which is 18. So just let's make a note there. We've added to get rid of Q. And then we just solve this like a normal equation. So I solve this now. So here, divided by 9, divided by 9. So P is equal to 2 there, like so. And then what I need to do, now this one here is a little bit trickier because the last time we subbed it into equation 2 because it was easier. Now the problem with this one here is that neither of them are easy or harder, okay? So I'm going to sub this in to, so let's just make a little note. Sub P into equation 1 to find Q. So I'm subbing this back into equation 1 to find Q. So equation 1 was this one. 4p plus 3q is equal to 5. And I know that p is equal to 2. So I'm putting this into here. Now this was what makes it a little bit trickier, okay? Because it's 4p. So with this one here, when I do this, it needs to be 4 times by p, which I know is 2, plus 3q is equal to 5. So with this one here, we've got to simplify our equation before we can solve it. We've got to do 4 times by 2, which is 8, plus 3q is equal to 5. And now I can solve my equation. So let's just make this a little bit smaller so I've got enough room. Okay. So the next stage I need to subtract 8. And if I subtract 8 from both sides, I end up with 3q is equal to minus 3. And then I need to divide both sides by 3. So divide by 3, divide by 3. Now, if I divide the right hand side by 3, negative 3 divided by 3 is equal to negative 1. And then we've got our two answers, so let's highlight them. P is equal to 2 and Q is equal to 1. P is equal to 2 and Q is equal to 1. So I'll give you a second just to get both of those down. So hopefully you've got that down. So I've got 2 questions here that I want you to have a go at. Maybe just have a little go at the one on the left first. So have a little go at that one on the left. And then I'll go through it in a second. So have a little go at that one on the left. Okay, I can see that some people have got this already, so I'm going to go through it. Let's have a little go. So, the first thing I need to think about is which of my symbols are the same. So, the symbols are the same on the... Sorry, the symbols, or the coefficients I should say, are the same on the Q. So, the coefficients on Q are both 1, aren't they? The number in front of it. Now, we don't usually write down 1Q. So, let's underline this. Now, are those symbols the same or are they different? Well, the symbols on Q are the same, which means that I need to subtract these equations. So 5p take away 3p is 2p. Q take away Q is nothing, we've eliminated that, that's the whole point. 20 take away 14 is 6. So it just leaves us with a linear equation, which is 2p equals 6. So then what I need to do is I need to divide by 2, so P is equal to 3. Now I've not finished there, I probably should have labelled these 1 and 2, because I still need to work out what Q is. So I'm going to sub P equals 3 into 1, equation 1, to find Q. So equation 1 is this, 5p plus Q is equal to 20. And I know that P is equal to 3. So I can say that if I put this into here, 5 times by 3 plus Q is equal to 20. So what is 5 times by 3? Well, 5 times by 3 is 15. So 15 plus Q is equal to 20. So then I need to minus 15 to get Q on its own. So Q is equal to 5. So my answers for this one are P is equal to 3 and Q is equal to 5. There we go. So hopefully you got that right. In fact, I'll probably write that down on the side just so we know. So P equals 3 when Q is equal to 5. Brilliant. So have a little go at that one on the right hand side now. Have a little go at that one on the right. Let's have a little go at some of these then. So, the first thing I need to think about is, are these the coefficients? We've got the y's here. The y's are the ones which are the same. And the question I'm asking myself is, are the coefficients on the, are the symbols on the y the same or are they different? Well, the symbols are different, which means that I add my equations. Okay? Because y plus minus y is equal to 0. So the symbols are different, which means I add. If the symbols were the same, then I would subtract. So then I need to add both of these. So 3x plus 2x is 5x. Minus y plus minus y is equal to nothing. That's the point. And 11 plus 4 is equal to 15. Then I need to solve this like a normal equation. So divided by 5, divided by 5. So x is equal to 3. There's our first one. And then we need to, I'll label these again, 1 and 2. I'm going to sub x equals 3 into 1 to find y in this case. So I know that x is equal to, the equation 1 is 3x plus y is equal to 11. And I know that x is equal to 3. So I'm putting this into here. Now 3x means 3 times x. And I know that x is 3. So it's going to be 3 times 3 plus y is equal to 11. Well, 3 times 3 is 9. So 9 plus y is equal to 11. So then minus 9, y is equal to 2. Brilliant. Okay. So if you're catching up at home, these are the questions I want you to have a little go at. If you're catching up, there's some questions there for you to have a little go at. And if you're catching up, these are your answers.